Hey mathletes, here we are in exponential functions. Let's solve some of these things algebraically. Now, as I say the word algebraically, what I'd like you to remember is every equation that I'm ever asked to solve in 30-1, I can graph and solve. So if you'd like to play around with that, for instance, on this first one, all you would do is this. Y2 would be this, and you're going to go find that x part of your point of intersection. Okay, I'm not going to do that with you right now. I think you guys and gals are all rather good at graphing things by now, but that's what I want you to think. Okay, if I'm stuck on a multiple choice numeric response question, hey, maybe I can just cheat. Okay, how are we going to solve these things algebraically though? Well, here's what we're going to do. We're going to look at this thing and we're going to say, okay, first thing I'm going to analyze is I'm going to analyze the bases. I'm going to go, okay, look at my bases are both 5. Well, this is an equation, which means the left-hand side is equal to the right-hand side. All right, well, if the bases are already the same, do you know what I know? Therefore, my exponents are equal. If this is an equation and the bases are the same, therefore my exponents are equal. That's it. Okay, I didn't divide the base of 5. I didn't cross them off. I simply logically don't need them. And I solve for x. There's my solution. X is equal to 2. I can easily check my work. Okay, that's a little too easy for us. Let's check out the next one. Let's go pretty purple. Okay, on the next one, what I notice is my bases aren't the same. So I'm going to make my bases the same. I'm going to make them both 7. And I'm going to say, okay, well, what's 343? Well, 343 is 7 cubed. And if I didn't know that, I just grab my calculator. Alrighty, bases are the same. Therefore, exponents are equal. And solve. Done skis. Okay, C. Let's go to, oh, pretty pink for C. What we're going to do here is I need to remember something from way back in grade 10, actually. First thing I'm going to do is I'm going to change 27 into 3 cubed. Yeah, no problem. But then what I need you to remember is a square root is exponent of a half. Now, I see all of these have a base of 3, but I can't just look at my exponents quite yet because there's 2 terms on this side. So I'm going to simplify this first. I'm going to add those together. Right? What do we get? That's 7 over 2. And now bases are the same. Therefore, exponents are equal. And I'm done. Not so bad, right? Okay. Now we're just going to take it up a tiny notch and let's look at a couple more. Okay, D, E, and F, these are kind of the level that I'm expecting to get on a test. Why do I say that? Well, because of this. My base isn't as obvious to me. So, well, I notice 27 is 3 cubed and 81 is 3 to the power 4. Let's make these both 3. So this will be 3 cubed, x minus 2, and 1 over 81. Well, 81 is really 3 to the negative 4, right? 1 over 81 is 3 to the negative 4. I'll write that down. 1 over 81 is 1 over 3 to the exponent 4, which again, going back to grade 10, is 3 to the negative 4. Now, from here, all we need to do is distribute. A very common mistake is failing to distribute correctly, and especially on the second one here, I'll see this a lot. I'll see plus 12. Well, we can all look at that and say, no, that's minus 12. For sure it is. But again, on a test, your pulse rate's up a bit, you're a bit stressed. Sometimes that's easy to forget. Okay, therefore bases are the same. Therefore, the exponents are equal. And just start isolating. And that's going to be -6 and -6/7. There it is. It's okay to have an answer that's negative. There's nothing wrong with that. Sometimes, for some reason, that freaks some students out the first time. And I'm like, no, 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 no. X can be negative. It's an exponential. The domain of an exponential is the real numbers. All right. E. Well, on E, again, I'm going to say to myself, my bases aren't the same. Why do they do this to me? And I also notice this is 49 here. So what I'm going to do right off the bat is I'm going to divide both sides by 49. Why I'm going to do that is I'm trying to solve for x, right? So I'm trying to get everything away from x that I can. Now what I'm noticing is, wait a minute, 144 is 12 squared, 49 is 7 squared. Okay, great. The two sides, the bases are starting to look the same. I'm going to rewrite this as 12/7 all squared. Okay, we're super close. I've got 7/12 as a base and 12/7 as a base. Well, they're reciprocals of each other. So how do we reciprocate? We change the sign on the exponent. So watch this. 7/12 is going to end up being to the -2. Again, there's another law from grade 10. Who knew Math 10C would be so important? Okay? And so now bases are the same, therefore exponents are equal. And after all of that hard work, I get x is equal to -1. Now, absolutely on a test, what I'm going to do is I'm going to verify that. I'm going to go and sub -1 back in here and make sure left-hand side equals right-hand side. All right. I'm going to get you to take a look at F. It looks very different than the other 5 we've done. I'm going to get you to hit pause, see if you can figure out how we're going to attack this one. Hit pause and think. Okay, hopefully you had time to think about that. Maybe you needed a sip of coffee for that one, and you say, I don't know. Okay, well, this one, when you first look at it, it looks different. Do you notice it almost looks like a trinomial? Do you see that? It almost looks like a trinomial. And it is. Some of you are saying, I don't see it. Doesn't look like a trinomial to me. Well, here's what I'm going to do. When I don't like the way something looks, I'm going to put some makeup on it. I'm going to make it look pretty. Let's do this. Okay, what just happened? He said, let's let a is equal to 4 to the exponent x. Why did he do that? Well, look at what we have now. A squared minus 6a plus 8 is equal to 0. I didn't change what it's equal to. I changed how it looks, right? I just dressed it up. That's all I did. Well, what do we do with trinomials? We factor those bad boys. We use the zero product property. We solve those bad boys. But now, friends, we didn't begin the question with a. We began the question with 4 to the exponent x. And so now we can solve the question we were asked to solve. Well, first one then is, therefore, I got a lot of therefores flying around, but x is equal to 1. And this one here, well, I'm going to make these bases the same, right? 4 is 2 to the exponent x. Bases are the same, therefore the exponents are equal. Therefore, x is a half. And guess what? There's our answers. So this one here, where we have to factor, where it's actually a trinomial, pops up from time to time. Now that you've seen it once, the next time you see it, you're going to be like, oh, yeah. That old guy was telling me about this. There you go. Again, keep in mind, friend, every one of these questions can be graphed and solved. There she is, solving exponential equations algebraically. Oh no, I'm going to say one more thing, and then you can turn me off. Bad teacher. Okay, how are you going to solve this one? Exponentially. This exponential, how are you going to solve that algebraically? Can you make the bases the same? Sir, no, sir. I can't make the bases the same. So for now, all you can do is solve that graphically. How do we solve it algebraically? We're going to learn something called a logarithm is going to help us solve that sucker. Okay, now you can turn me off. See you later, friends.